Many claim ethanol production uses more energy than it produces as a fuel. This is such a common belief that many people just assume it's true. However, ethanol has a positive energy balance and is already competitive with some petroleum-based fuels. The best way to get the most accurate picture of ethanol's energy efficiency is to calculate its energy return on investment, called the EROI ratio. This ratio compares the energy the fuel produces against all of the energy that goes into producing the fuel. For ethanol production, the EROI starts with the energy used to plant and harvest corn. This includes fuel needed to cultivate and harvest the crop, as well as the energy used to make seed, fertilizers, chemicals, farm equipment, and all the other inputs used in corn production. Also included is the transportation energy needed to ship corn to our plant and to ship ethanol and coal products to our customers. Finally, we must include the natural gas and electricity used in our plant to produce ethanol and our coal products. In total, we used about 46,000 BTUs of energy for each gallon of ethanol produced. Each gallon of ethanol contains 76,400 BTUs of energy that can be used as fuel. If we divide 76,400 by 46,000, we calculate an EROI ratio of 1.66. But to get a more accurate number, we also need to count the energy content of the livestock feeds we produce as co-products. This adds another 50,000 BTUs per gallon of ethanol and increases our total EROI to over 2.7. This is a significant improvement over the EROI that the USDA calculated for the ethanol industry in 2005 and shows how much more efficient corn and ethanol production have become in just 6 years. Also, corn and ethanol production uses very little gasoline or diesel. In 2011, we produced 21 gallons of ethanol for each gallon of petroleum fuel used to produce corn and ethanol. Why is ethanol's EROI so high? Because free solar energy provides most of the energy needed to grow corn. And most of the energy we use to produce ethanol comes from natural gas, a highly efficient, clean-burning fuel. Now, let's look at the EROI for oil and gasoline, which includes energy used in exploration and extraction. The EROI for oil production from a new well in the United States is about 6 at the wellhead. This is half of what it was 50 years ago. The EROI for oil produced from shale or tar sands is even lower, ranging from between 2 to 5. Then, even more energy is required to transport and refine oil into gasoline, diesel, and other petroleum products. By some estimates, ethanol already has an EROI 2 times that of shale oil, and it is not far behind crude oil for energy efficiency. As it turns out, ethanol provides an excellent return on the energy invested. In the future, ethanol production will become even more efficient, and its energy balance will continue to improve. However, it's predicted that oil's energy balance will continue to decrease, since it will take more and more energy each year to explore, drill, transport, and refine oil. If these trends continue, ethanol will become more energy efficient than gasoline produced from crude oil.